In the previous class on trigonometry, we learned all the prerequisites that was needed for it. Today we will start by learning some basic formulae and questions related to them. So the first set of formulae is of sine theta P by H, cos theta B by H, and tan theta P by B. So P denotes perpendicular, H denotes hypotenuse, B denotes base. These three different denotations for perpendicular, base and hypotenuse. There is a simple way to remember this. Some people have curly brown hair, turns permanently black. Okay, let us just recall what this perpendicular, hypotenuse and base were. Consider a right angle triangle. Suppose this is the base angle, say it's theta. This is 90 degree. The side opposite to the largest angle is the largest side. So hypotenuse is the largest side opposite to 90 degree. The side between the base angle and 90 degree is called the base. And the side opposite to theta is called perpendicular. Do remember that depending upon theta, we consider base and perpendicular. Hypotenuse do not change, it is always the side opposite to 90 degree. Here theta was at C, so we took the base between theta and 90 degree, this one BC. Here theta is over here, so between theta and 90 degree we take it as the base. Over here theta was here, so opposite to theta is hypotenuse, and 90 degrees here, 90 degree opposite to 90 degree is the hypotenuse, and between 90 degree and theta is the base. Okay, so next set of formulae is the reciprocal formulae. The plural for formula is formulae. So first is cosec theta. Cosec theta is 1 by sin theta. For this one, you can also remember that sin theta is 1 by cosec theta, and also sin theta into cosec theta is 1. Next is sec theta. Sec theta is 1 by cos theta. So from here we can say that cos theta into sec theta is 1. And last is the cot theta, which is 1 by tan theta, which implies cot theta into tan theta is equals to 1. After reciprocal formulae, we have quotient formulae. First one is tan theta, which is sin theta by cos theta and cot theta, which is cos theta by sin theta. We'll also look how to prove them. Let's take the right hand side, which is sin theta by cos theta, which is equals to, for the first one, for the tan theta one, right hand side is sin theta by cos theta. Sin theta is perpendicular by hypotenuse, curly brown hair. So perpendicular by hypotenuse into hypotenuse by perpendicular. Hypotenuse cancels out. We get perpendicular by base. And perpendicular by base is tan theta, which is equals to left hand side. Hence proved. Try the proof for cot theta on your own. It will you need to follow the same procedure. So we have some basic trigonometric formulae, reciprocal formulae, quotient formulae. Okay. Now we'll discuss some questions relating these. Type of question that you get over here is, say given tan n equals to 4 by 3. Find the other trigonometric ratios and of angle A. Further, prove that sin square theta plus cos square theta equals to 1. Okay. For this, first we'll consider a right angle triangle. So since we are dealing with the base angle as A, let's take this over here. This is angle A. Let's take 90 degree at B. It has not mentioned anything about the 90 degree. So we can take either B or C as our 90 degree. So B we took as 90 degree and say this is C. So suppose a triangle ABC, right angle at B, and let tan A equals to 4 by 3. Tan A turns permanently black, which is equals to BC by AP. After this, since this is in ratio, we'll let BC equals to 4K and AB equals to 3K. Why are we taking this K? Is because this ratio is 4 by 3. Maybe the size of these BC and AB might have been 40 centimeter and 30 centimeter. When they cancelled off, they become 4 and 3. That is why while considering BC and AB, we need to take a common ratio and let's call them as K. So BC we took as 4K and AB as 3K. By Pythagoras' theorem, AC square equals to AB square plus BC square, hypotenuse square AC square equals to base square AB square plus perpendicular square BC square, which implies AC square equals to 3k whole square plus 4k whole square, which implies AC square equals to 9k square plus 16k square, which implies AC equals to root under of 25k square. Root under 25 is 5, root under k square is k. So we get AC to be 5k. Now we need to find all the trigonometric ratios. So sine A becomes some people have. So 4 by 5. Cos A becomes curly brown hair. Tan A was given to us already, turns permanently black. Cosec A is 1 by sin A, so which will be equals to 5 by 4. Sec A is 1 by cos A, which is 5 by 3, and cot A is the reciprocal of tan A, which becomes 3 by 4. So for the second part, we need to prove that sin square theta plus cos square theta equals to 1. So let's take the left hand side. Left hand side is sin square theta plus cos square theta. We got sin theta to be 4 by 5 whole square plus cos theta is 3 by 5 whole square, which is equals to 60 by 25 plus 9 by 25, which is equals to 25 by 25, which is equals to 1. Hence the proof. Second type of question that you may get is, if angle B and angle C are acute angles, let's say angle Q are acute angles, such that angle B is equals to, sine of angle B equals to sine of angle Q, then prove that angle B equals to angle Q. Solution. Let us consider two right angle triangles ABC, we are not using the other alphabet. If we are using for angle P, then we make sure that we have ABC. For angle Q, we'll name it as PQR, where sine B equals to sine of angle Q. Okay. A, B, C. P, Q, R. So we have sine B equals to sine Q, which implies AC by BC equals to PR by QR. Over here sine B, some people have AC by BC. For sine Q in this triangle, some people have. So PR by QR. Okay. Which implies AC by, what we'll do over here is we'll take BC, which is in division, to the other side in multiplication, and PR, that is in the numerator in multiplication this side, will bring this to the denominator on this side. So AC by PR equals to BC by QR. We'll assume this to be K. Why are we doing this? Is because AC by PR, we are taking ratios of corresponding sides, equals to BC by QR. BC by QR. We have taken ratios of the corresponding side by changing this denominator with this numerator. Now, okay, so we have ratios for two sides. Now we'll take the ratio of the third side, AP by PQ. So AP by PQ, by Pythagoras theorem, we have BC square equals to AC square plus AB square. So AB square will become BC square minus AC square. AB square equals to BC square minus AC square by PQ square will become QR square minus PR square. I'll repeat this. BC square, the hypotenuse square, equals to AC square plus AB square. So AB square will be equals to BC square minus AC square. So BC square this will imply, if we take this and this, AC equals to K PR, and if we take this and this, we get BC equals to KQR. So we'll replace BC square with KQR whole square minus AC square equals to KPR whole square divided by QR square minus PR square, which is equals to K square QR square minus K square PR square by QR square minus PR square, which is equals to K square Q square minus PR square by QR square minus PR square. Both of this cancels out, which is equals to K square. So AB by PQ whole square equals to K square, which implies AB by PQ equals to K. Therefore, let's take this equation as 1. Let's take this as 2. Therefore, AC by PR equals to BC by QR equals to AB by PQ. We are combining equations 1 and 2. Hence, if we see, all the corresponding sides are proportional. AC by PR equals to BC by QR equals to AB by PQ. When all three sides are proportional, we call the triangles to be similar. Hence, ABC triangle is similar to triangle PQR. We denote the sign of similarity with this tilde sign. And if two triangles are similar, then their angles are equal. Hence, angle A, the corresponding angles will be equal. Angle A will be equals to angle P, and angle B equals to angle Q, and angle C equals to angle R. But what we needed to prove was angle B equals to angle Q, which we have proved. Hence, proved. Okay. You may also write side proportionality over here. And the third type of question that you may get over here is same triangle PQR, right angled at R, PQ equals to 7 centimeter, and PR minus QR is equals to 1 centimeter. Determine the values of sine Q and cos Q. This should be right angled at Q. Values of sine R and cos R. Okay, so we have a triangle PQR, right angled at Q. PQ is given to us as 7 centimeter, and the difference between PR and QR, PR minus QR, is given to us as 1 centimeter. This type of question we will change one into the other form. Say PR minus QR equals to 1 centimeter, which implies PR equals to 1 plus QR by Pythagoras theorem. PR square equals to PQ square plus QR square. So PR square, we'll write this as 1 plus QR whole square equals to PQ square becomes 7 square, and we'll let QR be QR itself, which implies 1 plus a square, a plus b whole square is a square, plus 2ab plus b square equals to 7 square plus QR square. We'll bring all the QR to one side and all the digits to the other side. So this is 2QR plus QR square plus QR square comes this side, becomes minus QR square equals to 7 square is 49, and 1 goes that side, minus 1, which implies 2QR equals to 48, which implies QR equals to 48 by 2, which is equals to 24 centimeter. Therefore, PR equals to 1 plus QR, which is equals to 25 centimeter. Hence, QR we found as 24 centimeter and PR as 25 centimeter. Now we need to find the values of sin R and cos R. While taking R as the base angle, this will become the base, this the perpendicular, and this will be the hypotenuse. So sin R some people have. So PQ by PR which is 7 by 25, and cos R curly brown hair, so QR by PR which is equals to 24 by 25. So these are the values. This three type of questions you are asked in this chapters. One is to find the values, where you might be given the difference between two sides. Other, you may be asked to prove two angles are equal when their sine or cos or tan is equal. And the first and the most basic type is where you will be given one trigonometric ratio and you will be asked to find all the other trigonometric ratios, or you need to solve some question like this. So this is your first class.